finish 2.6 today. We started it the other day, and I think we got all the way up through number 4. Am I correct on that?
Yeah.
Perfect. Okay, but we have not done number 5, 6, or 7. Okay, let's do a quick review. I know I taught this to you before the test, and I was like, it's not going to be on the test. So I also know some of us might not have been fully with it. That's okay. I want to remind you the things that we're doing on all of these problems. So we are in our reciprocal rational function unit. All of these are like fractions. There's x in the denominator, and this is what we need to do every single time. One thing that I don't have on here that I would always look to do first is look to factor, look to simplify. If you do factor or simplify, I put this at the end because this was the last thing I added. You have a whole, so if you have a canceled or a factored out kind of term, it becomes a whole. So I call that the canceled term. Our x-intercept is where your numerator is equal to 0, and your y-intercept is where you plug 0 in for all your x's. And hopefully you have this somewhere so you don't have to stress out too much about it. Hopefully it's already written down somewhere. Plug in x for 0 to get your x-intercept. Numerator equals 0 for your x-intercept. Might have just said those backwards. Whatever the board says is correct. Vertical asymptote is where your denominator equals 0. So set whatever's in the denominator equal to 0. And then horizontal asymptote, there's 3 different things. The first most common one that we do is if it's the same exponent and variable on top and bottom, then we just make a fraction of the leading coefficients. The next most common one that we do is where the denominator is smaller, or the denominator, excuse me, has a bigger exponent than the top. So like 1 over x or 1 over x squared. If the denominator has a bigger exponent, it's y equals 0 is your horizontal asymptote. And what we're going to get into today, I feel like I keep talking about this and like foreshadowing it, and we haven't really done anything with it yet, is if the top has an exponent that's bigger than the bottom, we have to use synthetic division to solve this. And it's actually going to be what we call a slant asymptote. So this is a slant asymptote, and we'll get to that later today. So I think I just have 3 more examples to do. One's a normal example, 2 have slant asymptotes. So we're going to go try those. Are you guys ready? Okay, that was a nice little review. Okay, so this is the first one. It says sketch it and label everything. So the very first thing I'm going to do is factor. What can I factor out? Let's see. Yes.
For the bottom one, to find the vertical asymptote, so like you put d5 out, so like 5 of x squared minus 1, and then x plus 1 x minus 1.
Good. I like to keep it, let's get it all factored out, and then we'll do our vertical asymptote from there. Because I'm afraid that something's going to change. We might get something canceled.
The top is x minus 5, x plus 1.
Good. And I'll write it out twice. Just kind of follow my work. You don't have to show all of these steps. If you can do this fast, you don't have to show all the steps that I did. But I couldn't do it faster. And now I easily see that that x plus 1 cancels out. That means that we have a whole. So we have a whole at -1. And now we're going to find the y for where that whole is at. Did you guys do that in algebra 2?
Yeah, you just plug it back in.
Just plug it back in. But what am I plugging it into?
The original equation.
I think I put it in the simplified equation, right?
Yeah.
Okay. Okay. I was tripping for a second. I was like, did I teach this wrong earlier? No, I think you put it in the simplified one. So I'm going to put it in here for this. We'll do -1 minus 5 over 5 times -1 minus 1. So that becomes -6 over 5 times -2, which is -6 over -10, which is 3/5. So it's at 3/5. All right, so that's my whole. I'm going to make a little mark. Remember that I got to graph my whole later. Okay. Now let's do our vertical and horizontal asymptotes. My vertical asymptote is my denominator. And like Ava said earlier, we're doing the denominator equal to 0. And we're going to set the simplified version down. So we're not going to go back to the beginning. We'll just stay here. So we'll say 5 times x minus 1 equals 0. Divide both sides by 5, x minus 1 equals 0, and then add 1 to both sides, x equals 1. Now I gotta do my horizontal asymptote, and this is an easy one. You can go back to the original equation if you want, or I can stay on the simplified version. I'm just looking at my biggest x and what exponent it's raised to. It's x to the first power, so I've got 1x and then 5x, so I make a fraction of 1 over 5. That's my y equals for my horizontal asymptote. Y equals 1/5. That was not a great explanation. Do I need to talk that out again, or do we know how to do it this way? Okay. All right, x-intercept, you set the numerator equal to 0, so x minus 5 equals 0, so x equals 5. And then y-intercept, that's where we plug 0 in for all of the x's, so 0 minus 5 over 5 times 0 minus 1. That becomes -5 over 5 times -1. Oh, or -5 over -5, which just is 1. That's easy. All right, once I have all those pieces, the whole, the vertical asymptote, the horizontal asymptote, the x-intercept, the y-intercept, we're gonna go graph all of that on a coordinate plane. So we need to go draw one since none of them are drawn right here. So I hope you left some space to draw a little axis. I need to go far enough so that I have a x-intercept of 5. So I need to go maybe past 5 on my x-axis. Once I've done that, I like to graph my asymptotes next. So I'm gonna graph my vertical asymptote at 1, my horizontal asymptote at 1/5. Go somewhere between 0 and 1, but closer to 0 if you can. Then we graph our intercepts. I'm gonna graph my x-intercept at 5, 1, 2, 3, 4, 5. My y-intercept is at +1. And then my whole is at -1/3. So I'm gonna go to -1/3 and graph an open circle. That's right about here. I don't quite know exactly where 3/5 is, but I know it's between 0 and 1, and I know it's bigger than 1/5. So it's gonna go somewhere in here. Once I have those, this is actually a really nice graph because I've got points on both quadrants that I need to graph my little C's in. So I'm just gonna graph my C's, approach my asymptote, go through my points needed. Approach my asymptotes, go through my points needed. Something like that. All right, that's it. Feeling okay on that one? Okay, the next one's almost the exact same, except our horizontal asymptote is gonna take a little bit more work. We're gonna do that one very last. So let's factor, let's find all the other pieces, and then we'll find our horizontal asymptote. Okay. We will factor, and it will not really give us anything new, but we're still gonna do it. So I still have x minus 2 on the bottom, and then my top becomes x plus 4, x plus 1. I can't factor that, I can't simplify, I can't do anything more, but it is nice to have it in this simple form as I have it. Since nothing canceled, I have no holes, so I'm gonna write holes and I'm gonna write none, just to make sure that I've covered my made sure I've checked everything I need to check. I'm gonna do my vertical asymptote next. X minus 2 equals 0. I told you we're gonna skip horizontal asymptote, so we'll do x-intercept, which is my numerator equals 0. I know we didn't use the factored form earlier, but it's actually super nice that it's factored now, because now I just know x equals -4 and x equals -1. Easy. No, it's okay.
All right, guys. Hey, just as a side note,
And then y-intercept plug 0 in for all the x's. I'm still using my factored version, so 0 plus 4 times 0 plus 1 over 0 minus 2. So that's gonna be 4 times 1 over -2. 4 divided by -2 is y equals -2. Sorry, did I go too fast? A little bit, okay. So for the y-intercept, I plugged 0 in for all my x's and I kept it in factored form. Yeah,
Isn't it supposed to be positive?
what's positive 2?
It was vertical.
VA, oh, okay. Oh, yeah, because I added 2 to both sides. Yeah, okay, I'm so sorry, yeah. Is that why everyone's freaking out? So I can't hear always what you say, but I can like see your faces and I just saw some like general chaos and I was like, what happened? Yes, definitely, that should be positive too. Andrew?
So I had a homework for algebra too. She had us write the x and y intercepts in like point form.
You can write them as ordered pairs.
So can we do order of pairs or can we do numbers? Like, would you count off the other one?
I would not count off either way. I think at like algebra 2, we're still trying to get you to do some like basic math correctly. So that's why she wants you to remember that the x-intercepts are the coordinate points, -4, 0, and then -1, 0. I am assuming at pre-cal you already know that, so I just skip that and I just say x equals. I would not count off points though either way. All right, let's make sure I didn't mess up again. My x-intercepts, change all those signs, okay, -4 and -1. 4 times 1 is 4, 0 minus 2 is -2, divided, that's -2, okay. Okay, sorry for that negative in the wrong spot, but I think everything else is right now, right? Okay, now, the horizontal asymptote this time is the third case scenario that we keep talking about, we have never done, we're finally gonna do. I have to do synthetic division to find the asymptote. However, I'm no longer gonna call it a horizontal asymptote. It's not a horizontal line anymore, it's gonna be a slant asymptote, because it's gonna be a line with a slope. So we are gonna do that by doing our synthetic division. So I'm gonna come over here. My -2, I'm going back to my original equation. My -2, x minus 2 is my factor. So I'm gonna put a 2 in the house. Remember, we have to switch the signs. If it was x minus 2, we have to put +2 in the house. Then I bring all my coefficients down, 1, 5, 4. And then I synthetically divide. So 1 times 2 is 2, 2 plus 5 is 7, 7 times 2 is 14, so that's 18. Now, when we do the synthetic division here, we often get a remainder. That's okay, I want you to ignore the remainder. It will not divide evenly or else it would have canceled earlier, so it's okay that we got a remainder. This though is now a polynomial. This says x plus 7. That's I like calling it a slant asymptote, but technically it's taking the spot of my horizontal asymptote. We had a pre-cal PLC the other day and Mrs. Ford likes calling it her end behavior asymptote. And we talked about how next year we need to talk about end behavior asymptote earlier instead of just horizontal asymptote, because that's technically what it is. Sometimes it's a horizontal line that's your end behavior asymptote, but sometimes it's a slant. So we like calling it the end behavior asymptote. So I will not change that on you guys this year, but I probably should change it next year for my next class. We're gonna graph this line as my asymptote. It's gonna be a slant line. So I'm gonna go graph my asymptotes first, and then we're gonna be able to see what else is going on here. Make your graph pretty big though, because I at least need to go up to +7 for my slant. I think I'm gonna make it a little bit off center where I have my x-axis not right in the middle. My x-axis is gonna be a little bit lower. So I can get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's good enough. Now mine will not be super exact because it's a sketch and my scale is not perfect. But again, I'm gonna graph my vertical and horizontal asymptote. So my vertical asymptote was at +2. bless you, and my slant asymptote's at x plus 7. So I'm gonna go to 7 on my x-axis, 1, 2, 3, 4, 5, 6, 7. And my slope is up 1 over 1. I hope Algebra 1 kids in the LRC with Algebra 1 stuff, and we're graphing lines like that. So we know we have to go up to the 7 on the x-axis, 7 on the y-axis, up 1 over 1, up 1 over 1 to do my slope from there. Up 1 over 1, up 1 over 1, up 1 over 1, down 1 over 1. Something like that.
Or do you do the same thing on this one? You do the other way?
Okay, now let's graph our intercepts. We have -4 and -1. And then y equals -2.
Alright, so guys, if you get here again.
Do you see how it looks like the quadrants that we've been doing? Like it still looks like we've got like 4 little quadrants. Like we'll call this one like 1, 2, 3, 4. Like I've got 4 different spaces to do my C's. I'm still gonna do the 2 that are opposite each other. So I've got points down here. So I'm gonna put a C curve in this spot up there. They're still going opposite of each other. What I wanna do now is connect my dots, and I wanna still approach the asymptote. So I'm gonna get close and close to the asymptotes. I'm gonna go through my points, and I'm gonna come back down and go close and close through my asymptotes again. Similarly up here, I'm just gonna do a little C that approaches both my asymptotes. So I've got a line up here, and then this line down here. The only weird thing we did here was that slant asymptote. Let's do another one like this. Are you guys ready? Do you want to start it on your own? Okay, I'll be quiet for a minute. You start this next one on your own. I'll start doing the work, but I'll do it silently.
And absolute value bars never ever change operations. And on that second problem, I don't want to change that.
I have my hole on the board, which is none. I have my vertical asymptote on the board, which is -2. I've got my x-intercept, which is -3 and +1. And I've got my y-intercept of -3/2. Everybody okay with those things? Now we gotta do our slant asymptote. So I know it's slant because these are different exponents and the one on top is bigger. This time when I do my synthetic division, I'm gonna put -2 in the house because it's x plus 2 on the bottom, switch the signs, put my coefficients, and then divide. once you divide, you get that remainder, and then remember, we don't worry about the remainder. We can ignore him. It's just x. This equation is y equals x. You can think of it as y equals x plus 0. 0 is my y-intercept, so I'm going to go through the origin, and my slope is just 1. So I'm just going to go up 1, over 1, up 1, over 1, up 1, over 1. So I'm going to go graph that. I'm going to go graph all my other pieces, and we're going to see what happens. So 0, 0, up 1, over 1. And then you just extend your asymptote out. My vertical asymptote's at -2. My x-intercepts are at +1 and -3. And my y-intercept is at -3/2, which is somewhere between 0 and, or sorry, -1 and -2. And then once I have these points, I'm gonna keep that C curve, but again, it's gonna be a little flatter than normal because I'm gonna extend it along close to the asymptote. So I'm gonna make it close to the asymptote. I'm gonna go through my 2 points. I'm gonna go to the other asymptote. Same thing with this up here. I'm gonna be close to the asymptote. I'm gonna go through my point. I'm gonna go close to the asymptote again. So it's these 2 lines right here. Good?
Yeah, sorry.
I couldn't tell if it was like a tired stare at me or if a confused stare.
Oh, no, it's that side. Sorry. There's different.
Okay. The phone call or an alarm?
Random number.
Oh, I hate that.
Wire syndrome.
Trying to contact you on my car's extended warranty.
I hate random phone calls. Okay, that is the end of 2.6. So now this is when I kind of pause and say, remember, 2.6 is due next time I see you, which is Tuesday, because Monday's at day 1. So Tuesday, you guys have 2.6 due. Okay, we're gonna get into 2.7 today. I need to get to number 6. If we get to number 6 before class is over, then we're done. If we don't, then we're gonna have an issue. This, though, I think is a little bit more fun than what we were doing. We're just solving equations. Now, that being said, did you guys use the phrase cancel, wait, is that the one I want to cancel the denominator? Dang it, I had it this morning. Clear the denominator. Did you guys use that? Clear the denominator? Okay. I'm so sorry. I think I've got Friday brain because I just feel like a little foggy today. Clear the denominator. That means that whatever's in the denominator, we're going to multiply by the entire equation to get rid of it. Sometimes you guys want to get like denominators. I just think that gets a little messy sometimes. So what I'd rather you do is clear the denominator. So multiply by whatever's in the denominator by everything. So in this one, we're going to multiply everything by x. Since x is my only thing in the denominator, we're going to clear the denominator by multiplying everything by x. So x times x is x squared. X times 3 over x is just 3. And then x times 4 is 4x. The biggest mistake is we forget to give it to the opposite side. Do not stop at the equal sign. You have to give it to every single thing in the equation. Everything. And now I have no denominators. This looks like an algebra 1 problem, or at least an algebra 2 problem, right? I would get, every time you have a quadratic, move everything to one side, so I'm gonna minus that 4x from both sides. So I get x squared minus 4x plus 3 equals 0. And when you have a quadratic equals 0, you can either factor or quadratic formula. I think this one factors pretty nicely, right?
Yep.
What is it gonna be?
X minus 3 and x minus 4.
Good. X minus 3 and x minus 1, which means x equals what?
1 and
1 and 3. That's my answer. That's it. That's pretty easy, right? That's pretty easy. Let's do another one. What am I going to multiply by everything on this one?
3. X minus 4.
X minus 4. Now, I do like to be extra careful on this one. I'm going to do x minus 4 times x, and I'm going to write it over here like this. X minus 4 times x. So I can distribute it out. Then when I do x minus 4 times 1 over x minus 4, the x minus 4's cancel, and I'm left with 1. And then x minus 4 times 0, well, anything times 0 is just 0. X times x minus 4 plus 1 equals 0. Distribute that x. X squared minus 4x plus 1 equals 0. And then now again have a quadratic where I can either factor it or do quadratic formula. I would argue that this is probably not a very good factoring problem. It doesn't factor easily, so let's do quadratic formula. I've got A, I've got B, I've got C. Let's plug and chug. X equals negative B, so positive 4 plus or minus B squared minus 4 times A times C, and then all over 2 times A. Personally, if I was you, every time we can do a quadratic formula, I'd be like, heck yeah, because we could do way harder stuff. I'd much rather do a quadratic formula. 4 plus or minus 16 minus 4 all over 2. And then 16 minus 4 is going to be 12. 4 plus or minus root 12 over 2. Can we simplify radical 12?
Yep.
2.
2 root 3.
Good. 2 root 3. And then can I do anything else?
Right.
What does it simplify all the way down to?
2 plus or minus 2.
Good. These are both ones, but if you write the ones in there, it's redundant. Do not write the ones, but you do need to write that too. So 2 plus or minus root 3 is probably your best answer. So that's what x equals. All right, smooth sailing so far, right? Okay, the next two are still smooth sailing, but I've got a couple other types of things to look at while we're here. Now I've got a lot more on my denominators. My denominators are a lot busier on this one. What I would do first is if you have something in all 3 denominators, I'd see if you can factor down the biggest, most complicated looking one. So I've got x minus 1, I've got x minus 3, and I've got x squared minus 4x plus 3. What is it? X 3, x minus 3, x minus 1. So we look to see if we can factor it down. If it's the exact same things that are already in the denominators, that's awesome because we're already going to multiply and get rid of them. If it includes something new, then we also need to multiply by that. All the other problems we've done so far, we've only multiplied by one thing. I'm going to multiply by 2. I'm going to multiply by x minus 1 and by x minus 3. At least one thing, if not both, will cancel on all of these terms, so it will all kind of look a little bit more simple momentarily. The first one I've got 2x over x minus 1, so the x minus 1's cancel, and I get 2x times x minus 3. Then I do 1 over x minus 3 times x minus 1 times x minus 3, and the x minus 3's cancel, so I get 1 and x minus 1. And then on this last one, I've got an x minus 3 in the denominator, so those cancel, and I've got an x minus 1 in the denominator, so both of those cancel. So I'm just left with a 2. Multiply, multiply. 2x squared minus 6x plus x minus 1. Equals 2. Now let's combine like terms. I'm gonna move the 2 to the other side, so I'll minus 2, and at the same time combine those two, so I get 2x squared minus 5x minus 3. And I again have a quadratic. You can either factor or quadratic formula. Can we factor this one though? I think we can. 3 and 1.
Oh, yeah.
Minus plus x minus 6x. Yeah, okay. It's kind of a tough one, but I got it. If I was messed up and I thought I couldn't factor though, you can always do quadratic formula and you'll still get the right answers. So I just need to set each of those factors equal to 0. So I'm going to do 2x plus 1 equals 0. So 2x equals negative 1, x equals negative 1/2. And then x minus 3 equals 0. So x equals 3. Okay. Now, have you guys learned about the term extraneous solutions? Okay. What here is an extraneous solution? Andrew?
3, and it's because, you said your denominators, equal to 0, and that's how you find them, and you have to note at the beginning that it's going to do that, so it was like, really like, working equations in the beginning.
Exactly. So I like what you said at the beginning, Andrew, is you said we make note that we can't have positive 1 and we can't have 3, right? So you're welcome to do that at the beginning, be like, what would count as an extraneous solution? What cannot be an answer? What is not in our domain? 1 and positive 3 are. So when we have positive 3, that doesn't count as a real solution. I like to list it though. I like to write it as extraneous solution x equals 3 and count that just as part of my answer to show, like I knew 3 worked, but it should not actually work when you logistically plug it in. Okay. All right, there's another one like this. You want to try the next one on your own? Okay, try that one on your own. They're both extraneous. So in this case, I solved, I found answers, but they're both extraneous. We call this no solution. There's no real number that actually works to plug in. So those are my extraneous solutions. Technically, there is no solution here. I got 2 more problems I want to do. Everybody hanging with me? Taking a nap? Okay, 5 and 6. These are what we call work problems. They are word problems because they're made up of words, but they are also called work problems because we're doing work. This is kind of a weird little formula setup, so I understand that it might be confusing. The first problem says Jessica can finish painting a room in 5 hours. It takes Brenda 6 hours. How long will it take them together? Okay. What I like to think about is separating it. So when I write my equations, I think of it as 1 over how long it takes one person to do it alone, plus 1 over how long it takes the other person to do it alone equals 1 over how much it takes them to do it together. We're dealing with fractions essentially. So the first fraction represents Jessica. So Jessica can paint a room in 5 hours. So we're gonna represent that as 1 over 5, which makes sense. In 1 hour, she can get a fifth of the room painted. Brenda takes 6 hours though, so in 1 hour, she's gonna have 1/6 of the room painted. We don't know how long it's gonna take them to do it if they do it at the same time, if they do it together. So we're gonna use an X to represent that. So we'll say that equals 1 over X. Now I have a little fraction equation and we can solve this by clearing the denominators like we were just doing. What should I multiply by everything to clear this denominator, Ryan?
30x.
What'd you say?
30x.
30x? 30x. 5 times 6 is 30, times x is x. That's the smallest number I can do to multiply and get rid of everything. So as I multiply 30x divided by 5, will cancel and get me 6, so I'm left with 6x. 30x divided by 6 will cancel and leave me with 5x. And the last one, it's 30x divided by x, so the x is gonna be the thing that cancels out and I'm left with just 30. Let me actually rewrite that up over here so I can actually do some work out. Whoa, come back. Six x plus 5x equals 30. And now that looks like a simple algebra 1 equation, right? 6 plus 5 is 11x equals 30. 11 divided from 30, 30 divided by 11. If you said it took them 30 divided by 11 hours, I'd be like, that doesn't mean anything to me. So let's make it into a decimal, 2.7 hours. 2.7 hours is how long it will take them to do together. If they work together, that's how long it will take. I promise there'll be a question like that on the next test. I promise, promise, promise. Now, to kind of really send this point home, we're gonna do one more just like it. It's got like one more little piece to it, but it's similar to this thought. Anybody have any questions on that before I move on to the last one that I want to do today? This one says, a drain is left open as a pool is filling. Hose X can fill it in 10 hours and hose Y can fill it in 4. If both hoses are running and the drain is open, it takes 15 hours to fill the pool. How long does it take to drain the empty pool once it's full? Okay. Sounds silly to know that it takes 15 hours to have both hoses and the drain open. That feels like a big waste of water, but I didn't write this problem, so. This time we're doing 1 over alone plus 1 over alone, but then we have to do something with the drain. Is the drain adding, is it the drain helping me or is it like hurting me as I do my work? It's hurting me, right? It's like if I had a little kid and I was cleaning the house and they kept undoing everything I just did, right? So the drain's hurting us. So we're gonna still do 1 over alone plus 1 over alone, but I'm gonna minus off the drain work. I just don't know how long it's gonna take it to drain. So I'm gonna call that 1 over x because that's what we're solving for. If all 3 of those things happen together, it's gonna be 1 over together. You could skip the step I just did. I just wanted to explain what I'm thinking. And now I'm going to put those numbers in. So the first hose is hose X. How long does it take hose X to work? Hose Y is 4, but I can do hose Y first. I don't care. What's the other hose then? 10. Good. So one's 10, one's 4. It doesn't matter which one goes first. No, it doesn't matter. Remember, addition is commutative, so 1 over 10 plus 1 over 4 is the same thing as 1 over 4 plus 1 over 10. It doesn't matter. And then I'm going to minus that 1 over x, and then that equals 1 over, how long is it if all of these 3 things are happening at the same time? 15. Okay, so now I need to multiply by something to get rid of all of these things. You can just multiply all of those numbers together. You just might have a little bit of bigger numbers. Or you can try and figure out what the smallest thing you can multiply by is. Is it 60x?
students.
You feel good? I feel good. Okay, so we'll do 60x divided by 4 or 60x times 1/4. Is that 15x? Okay. And then 60x times 1/10 is going to be 6x. And then times -1/x will be -60. And then 60x times 1/5 is going to be 4x, I believe. Even though I have more x's than last time, it's still an algebra 1 thing because I just have x's, I'm going to add them together. So I'm going to combine all my x's. I'll combine these two over here first. That becomes 21x minus 60 equals 4x. And then as I move it, I'm going to move the 21 over to that side. I'm going to minus 21x from both sides. Which might seem kind of silly because I've got a lot of negatives going on, but negative 60 is going to be equal to negative 17. And I can divide by negative 17, and negative divided by negative is a positive, so it will all work out in the end. Again, 60 divided by 17 isn't really a real number, so I'm going to make it a decimal, 3.5. That's how long it takes the drain to go. And I believe that's in terms of hours. So it takes 3.5 hours, ooh, come back, to drain the swimming pool. Now, you maybe can start your 2.7 homework, but I still have a handful of word problems. I'm going to give us time to do these word problems and then some of 2.8 next class. So that's all I've got for today.